We all know that the planets in our solar system, or rather in any solar system, revolves around a star. In case of our solar system, it is the sun. And also, moons revolve around planets. And Earth, as we know, our moon also revolves around the Earth. And also, we know that whenever we throw any object up in the air, it is going to come back down, right? Right, we all know these things. So basically, these two things that I'm considering at the moment. There's a movement of the planets around the sun, and falling of, say, a ball from above, or rather, of any object from the air which we throw up, or basically we can consider any object falling. For example, apple from a tree. Yeah, does that sound familiar? So, falling of an apple from a tree and movement of the planets around the sun. These two phenomena, I can say, looks somewhat different, but interestingly, they are because of the same cause. I think I can say, because of the same reason. So, Sir Isaac Newton gave us the universal law of gravitation, which said that the force, there is always a force, okay, which is attractive in nature, always a force that exists, that pulls two bodies, right? And that force is directly proportional to the masses of the two bodies, right? And the force is inversely proportional to the distance between them, right? So basically, that's the universal law of gravitation, but this is the more precise form of that law. G m1 m2 by r squared. That is, when we remove this proportional sign, we have to give a constant in order to bring the equal sign. So this is the law of universal law of gravitation. Okay, here, let me clear the screen now. Here, the value of G, let me select the pen here, the value of G is 6.667 into 10 to the power minus 11 Newton meter square plus by kg square. Newton meter square by kg square. This is the value of the universal gravitational constant. It is interesting to think that why we are so lucky that the universal gravitational constant has this value. Had it been even slightly more different, then we would not have existed. In fact, the whole universe would not have been the way it is today. Well, as we all know that the universe started when the universe basically formed after the Big Bang. And because of the gravitational force that exists between the masses in the universe, the bodies are held together by the right amount of force so that different important elements can be formed, right? For example, the stars were formed, right, by because different, the right amount of quantity came together because of the right amount of force was present. Not just gravitational force, we know many other forces, but just simplifying the overall picture, we are just talking about we are just discussing about the gravitational force right now. So if the gravitational force, say, has a greater value, had a greater value than the one that we have now, then all the different bodies might just come together and collide, and there would not be any life on this universe. And say if the gravitational force was less powerful than it is right now, then all the bodies might just drift away. Because the universe is expanding, these bodies might just drift away, and no required amount of elements might come together. Not just elements or any other substance might come together and give the present form of the universe. So, well, I have drifted too much away from the main topic, but this is the reason, this why this theory is also considered to be very important, because it explained us a whole lot of stuff which on the first glance looks very different, but they are actually because of the same reason, right? And also this law gave a mathematical form to a physical phenomena, right? So this was the first law, in fact, which gave a mathematical explanation to a physical phenomena. So that is why this is considered to be one of the most important discoveries of the human mind. Hope you enjoyed.